So we talked about over here, we have our diatomic molecules, right? So we have, let's remind me of our diatomic molecules, our weekly reminder. We should all be getting pretty good at this. So diatomic molecules, let's go. Just shout them out. So H2 I heard, N2 I heard, O2, F2, Cl2, Br2, and I2. Okay, these are our diatomic molecules, and our polyatomic, we have two. Joanna, could you tell me one?
S8.
S8, yeah, for sure. Tanner, and what's the other one?
Was it P4?
Yeah, you bet.
Go for S.
Oh, yeah, P4, good. S8. Excellent. Okay, so we have 7 diatomic and then 2 polyatomic. Okay, so if we just had like 1 mole of oxygen, it would be 16 grams. Okay, as it says on here, the molar mass of oxygen is 16 grams per mole. So if we have 1 mole, that's 16 grams. If it is 1 mole of diatomic oxygen, however, because there are 2 oxygens that are present, okay, it would be 16 grams times 2, because there's 2 oxygens present. So the molar mass of diatomic oxygen is 32 grams. Okay, this is always true. These values here, we found this on the periodic table, right? And then just another example, so 1 mole of nitrogen from the periodic table, if it's just N, it would be 14.01 grams per mole. However, if it is diatomic nitrogen, there are 2 nitrogens present now, so the molar mass of diatomic nitrogen is 28.02 grams per mole. Okay, we're all good with that so far? Yeah? Excellent. We're going to skip that one for now. Okay, so finding molar mass of compounds. So when we're doing this, we need to combine our naming skills also with our periodic skills. Okay, so all of this is kind of coming together, right? Okay, so sodium chloride. What type of a compound is sodium chloride? Ionic compound, okay. So this is an ionic compound. Therefore, what do I have to take into consideration here? Net charge is 0. Very good. Okay, so now I'm going to go from the name, sodium chloride, to the chemical formula. Okay, so sodium is a group 1 metal. So this means it always has a charge of what, Arian? +1. Very good. So Na has a charge of +1. And Tanner, chlorine is a halogen, which means it always has a charge of? -1. Very good. Okay. So -1. So +1, -1 has a net charge of 0, right, Brody? Yeah? Okay, so we can just go NaCl. So that is the formula for sodium chloride. Okay? But we're finding the molar mass now. Okay? So we have only found our formula. So now we need to find the molar mass. Okay? So what we are finding right now, we're trying to find the big M. So the molar mass of sample element. This can be a compound or an element, I should fix. Okay, sometimes we need to like put them together, right? So we're looking for the big M, which is molar mass of compound. So to find the molar mass of the compound, we need to first find the molar mass of each element in the compound, okay? So, we'll start with sodium. So sodium has a molar mass of 22.99 grams per mole, okay? So 22.99 grams per mole. Okay, and then we're gonna go for chlorine. Has a mass of 35.45 grams per mole. Okay, so now that we've found the mass of the sodium and the mass of the chlorine, now we need to find the molar mass of the compound. Okay, so we can just add these together. So NaCl is equal to, so this is where you guys should have your calculators out. .44 grams per mole. And again, this would be our big M, because this is the molar mass of a compound, okay? Molar mass of the compound. Any questions there? So when we're just finding the molar mass, okay, we just need to, if we're trying to define the molar mass of a compound, we just need to add the molar mass of each of the element making up that compound, and that will give us the molar mass of the compound, okay? Okay, so moving on to methane. Okay, so what type of compound is methane? It's a molecular compound, right? Very good. We have carbon and oxygen. It is two nonmetals, so it's a molecular compound. Okay, so that is all good. And we're actually given the chemical formula here, CH4. Okay, so how many? So now we need to find the molar mass of the carbons and the hydrogens. Okay, but let me ask you guys something. How many carbons are present in methane? 1. Okay, very good. And how many hydrogens are present in methane? 4. Okay. So when we just have to take that into consideration when we're finding the molar mass, because of course there are 4 methanes, so we need to multiply the molar mass of hydrogen by 4, right? In our last example, sodium chloride, there was only 1 sodium and 1 chlorine, so we didn't have to do any multiplying there. But because we have 4 hydrogens, we do need to multiply that, okay? So, we'll start with the carbon, which from the periodic table, the molar mass of carbon is 12.01 grams per mole. And hydrogen, and there are 4 of them, so I'm going to write H4 is equal to, hydrogen has a molar mass of 1.01 grams per mole. So I'm going to use brackets here because I want to multiply the H by 4, not the carbon or anything else. Okay, so I'm going to do 1.01 grams per mole times 4. Right, because we have 4 hydrogens present and only 1 carbon present, so that's what we're going to do there. And then, so when you do that into your calculator, when you enter that into your calculator, I would recommend that you guys do it like this. So 12.01 plus 1.01 times 4 is how I would do that. And if you do that, you'll get a molar mass of 16.05 grams per mole. Okay, so the molar mass of sodium chloride is always going to be 58.44 grams per mole. The molar mass of methane will always be 16.05 grams per mole. Okay? Always. These molar masses will not change. All good? Okay, so you guys try these on your own, please. Okay, so our first one here, we have iron oxide, okay? And yeah, so let's just get going. So iron, well, I'll start with iron, and we just have one of them, so that's easy. Iron has a molar mass of 55.85 grams per mole. Okay, and make sure you guys are including units when you're doing your calculations, okay? Because what is a number without units? Meaningless, right? Exactly, it's just a number. Like, if I said I had 13, you guys would be like, you had 13 what? Right? 13 hours of sleep? $13 in my pocket, right? So make sure we include units on our numbers, okay? Very important. Okay, so iron has a molar mass of 55.85 grams per mole. Oxygen has a molar mass of 16 grams per mole. So iron oxide has a molar mass of 71.85 grams per mole. Okay, so let's just keep going. So now we have, if I wanted to name this one, so what is the common charge on oxygen always? -2. So what would be the name of this first compound here? Yeah, perfect. Iron 2 oxide. Good. Okay, so let's do the second one now. So we have, this is going to be iron 3 oxide. Okay, so we have 2 irons. So we're just going to do 55.85 grams per mole times 2. And O3 is going to be 16 grams per mole times 3. So we'll do that. And what do we get for iron 3 oxide?
159.7 grams per mole.
Excellent. 159.7 grams per mole. Right, able to get that one? Yeah? Okay, good. Okay, let's keep going. So try these ones on your own. Okay, so Br2, this is bromine gas. Remember, this is a diatomic molecule. So bromine 2 is equal to, so 1 mole of bromine is 79.9 grams per mole. And we have 2 of them. What did you guys get? 159.8 grams per mole. Good. And again, the molar mass of bromine gas will always be 159.8 grams per mole. Okay, always. Okay, on to the next one. So this is nitrogen dioxide. Okay, so we only have one nitrogen and two oxygens. So N is 14.01 grams per mole. And O2, oxygen has a molar mass of 16 grams per mole. And there's two of them. So molar mass of nitrogen dioxide is what? 46.01 grams per mole. Good. How are we feeling about these? Pretty good? Yeah? Excellent. That's what I like to hear. Okay, so that was the molar mass of sample or compound, okay? So that was looking for big M. And now we're going to go to finding the mass from the number of moles. Okay, so now we're going to start using this actual formula themselves. Okay? Okay, so I'm not going to make you guys calculate the molar mass again because I know you've already found it. Okay, but now we're just going to go from the amount of moles to the mass of the sample, okay? So, if we wanted to isolate for our little m there, so if we have, so N is equal to the number of moles, which is equal to the mass of the sample divided by the molar mass. Okay? This is our formula, right? Now, if you wanted to find the mass, okay, how would we get this little m by itself? Yeah.
You would multiply the big M by the little m. And
Yeah, perfect. We're going to multiply both sides by big M, right? Yeah, excellent. Because we are dividing by big M, the opposite of dividing by big M is multiplying by big M, okay? So multiply by big M. So now our M divided by M will cancel. And now we're left with little m is equal to big M times the number of moles. So in this first question, what is my little n? 5, right? Excellent. Because n is the number of moles, and it says right here we have 5 moles of NaCl, okay? Now we calculated the molar mass of sodium chloride a few questions ago, okay? So big M is equal to 58.44 grams per mole. Okay, so now our little m is just going to be our big M multiplied by the little n. So we have 58.44 grams per mole multiplied by 5 moles. Okay, our mole units will cancel because we have grams divided by mole, and we just have 5 moles, so moles divided by moles will cancel, and then our little m is going to be 292.2 grams of NaCl. So this is like the mass of our sample in this question, okay? So if we have 5 moles of sodium chloride, this is the same thing as saying we have 292.2 grams of sodium chloride, okay? Just a different unit of measurement. Grams versus moles. Close, they're definitely related, but not similar, okay? So same, but different, in a sense. Okay, we feeling pretty good? Hold that one, yep. Okay, so same thing. Last couple slides ago, we calculated the molar mass of methane to be 16.05 grams per mole. And we're looking for the little m. What is my n here? 2. Okay, we have 2 moles. Little n is number of moles. Okay, so little m is equal to 16.05 grams per mole multiplied by 2 moles. Again, moles cancel, and we're going to be left with our mass of sample is 32.10 grams of methane. Questions? Concerns? You guys want to try a few on your own? Yeah. Okay, so same thing. We'll find the mass of iron 2 oxide and iron 3 oxide. Alright, so same as last slide. So remember our formula. Number of moles is equal to mass of sample divided by molar mass. We're looking for the mass of sample. Okay, so we need to isolate for little m. So we'll multiply both sides. Now we're left with m. Okay, so we calculated the molar mass of iron 2 oxide to be 71.85 grams per mole. Okay, and we have 3 moles that are present. So we get a value of 215.6 grams of iron 2 oxide. Okay, iron 3 oxide, we had big M as 159.7 grams per mole. We have 3 moles present, so our units will cancel, just like they did up here. Okay, and we will get a value of 479.1 grams of Fe2O3. We're good? Okay. How are we feeling with mass from number of moles? Do you guys want to do another example, or do you want to move on to next thing? Let's do one more example here. All right, so diatomic bromine gas. We calculated the molar mass of bromine gas to be 159.8 grams per mole, and we have 10 moles present. oops, that's a multiply, sorry. Multiply by 10 moles, so we can actually just move that over one. And we get 1,598 grams of BR2. And nitrogen dioxide has a molar mass of 32 grams per mole. In this particular question, we have 7 moles. So our mole units will cancel. And we are left with, where are we? 224.0 grams of nitrogen dioxide. Okay, how we doing? Are we all, we're cruising through? We're mole masters right now. Good. Okay, I'm gonna jump ahead a bit. So you guys are going to be completing all those problems that we didn't do together, okay, in this mole booklet. So some of these examples that we skipped through, you guys are going to be working on them for the remainder of today's class, okay, once we're done. Okay, so next is finding the amount of moles from mass. Okay, so in this case, we will be given M, so little m, which is mass of sample, and usually we will need to calculate big M, the molar mass. Okay, and I really hope that little m and big M are not confusing for you two, or for you guys, okay? Yeah, we just need to know that the little m is the mass of the sample, and I'll show you an example of what I mean in a minute, and then big M is going to be the molar mass of the sample, okay? Okay, so now we are given just a mass, okay? Yeah, so this is what I mean by this. So we have 50.5 grams of sodium chloride. This is the mass of our sample, okay? So this is our little m, okay? So little m is equal to 50.5 grams. What did we calculate the molar mass to be of sodium chloride? 54.88 grams per mole. No, 58.44, sorry. Okay, now we have little m, we have big M, and we're looking for N, which is convenient. We don't even have to manipulate anything. So as per our formula, number of moles is equal to mass of sample divided by the molar mass. So in this case, the mass of our sample is 50.5 grams divided by our molar mass. So what is the molar mass of our compound? Is 58.44 grams per mole, which is equal to 0.864 what? What are my units going to be on here?
Moles.
Moles, right? Yeah, good. It's because our grams, a gram divided by a gram will cancel, and then we'll be just left with moles, you bet. So if we are given a 50.5 gram sample of sodium chloride, this means we also have 0.864 of a mole of sodium chloride. Okay? Now, when you get these answers, I would just, look at them again. Because if you have, if your numerator is smaller than your denominator, you should get a number less than 1, right? It's kind of like a test grade, right? If you got, 9 out of 10%, you got 90% on the grade. In this case, let's just say we had a molar mass of 10 and a 9 gram sample, you would have 9/10 of a mole, 0.9 of a mole, right? Does that make sense? Okay? So conversely, if the mass of your sample is larger than the molar mass of your compound, then you should expect to have more than 1 moles, right? So if you have 12 grams and your molar mass was 10, you would have 1.2 moles of something, right? So just take a look at that, because I've seen it very often where students will actually get these swapped up, or they'll divide the wrong thing by the wrong thing. Okay, so just be conscious of that. Okay. Okay, so we'll move on to methane now. So we have 20 grams of methane. So what is that? Is that my big M or my little m? Little m. Good. That is the mass of my sample. So little m is equal to 20 grams. We calculated a few slides ago that the molar mass of methane is 16.05 grams per mole. So to find the number of moles, we're just going to divide our little m by our big N. So N is equal to 20 grams divided by 16.05 grams per mole. And we will get 1.25 moles of methane. All right. So try this next one on your own, please. So just had a question asking how many decimal places that we need to round to. That is a really good question. Usually I wait until physics to talk about significant digits. Okay, but if you want to just start doing that right now. Typically, the amount of numbers that are given in the question is how many decimal places or how many digits you should give your answer in. Okay, so let's go through this one and I'll show you what I mean. Okay, so what is my mass of sample for iron 2 oxide? What is my mass of sample, Tanner? 80 grams, very good. So that's little m. And the molar mass of iron 2 oxide is 71.85 grams per mole. So number of moles is equal to mass of sample divided by molar mass. So we have 80 grams divided by 71.85 grams per mole. And we get N is equal to, how many decimal places did you guys get for this? It was just to 2? Did it end at 2?
No.
How long did it go for? Do you mind reading it off for me? 07? Yeah. 9. We'll just stop there. That's okay. Okay. So yeah. This has 1, 2, 3, 4, 5, 6, 7, 8, 9 digits, right? So yeah, you don't need to give your digits with that many. A good rule of thumb is, so in this question, 80, we call them significant digits, okay? So in here, we have 2 significant digits. So you should, if I give you something that has 2 digits in the question, you should also give your answer with something that has 2 digits, okay? So in this case, N would be 1.1 mole. Really good question. Okay, I'll leave you guys to do this one on your own. I'll tell you the answer. N is equal to 0.50 mole for this guy. Okay, and I just want to jump ahead and do one that we haven't. Do one where we haven't calculated the molar mass yet. So let's do this one right here. And then I will let you guys practice for the remainder of class. Okay, so first thing that we need to do here is find the molar mass of magnesium chloride. Okay, so magnesium has a molar mass of 24.31 grams per mole. And chlorine has a mass of 35.45 grams per mole. How many chlorines do we have though? 2. Okay, so multiply by 2. Okay, so punch those into our calculator. We will get a molar mass of 95.21 grams per mole. So this is our big M, right? This is our molar mass. So that is a big M. What is my little m? What is my mass of sample? 45 grams, good. So don't forget, N number of moles is equal to mass of sample divided by molar mass. So now let's just put those into that formula. So N is equal to mass of sample, 45 grams, divided by our molar mass, 95.21 grams per mole. And if we do that, we get a value of 0.472 mole. I'm okay if you leave it like this, but if you want to give this with like significant digits, I would round this to only 2 digits, right? So this would be 0.47 mole. Okay, either one of those answers is totally fine with me. Okay.
Is it gonna matter on the tests how many digits you have?
Not in the chemistry unit, but when we get to physics, it will. Okay, and we're gonna go over significant digits once we get to physics. Okay, so don't worry too much about this. But if you wanted to give the best answer, this would be it. Okay, good. Okay, last one we're going to do together here. So let's calculate the molar mass of sodium chloride. So Na is 22.99 grams per mole. Oxygen is 16 grams per mole. and hydrogen is 1.01 grams per mole. So NaOH is equal to a nice even 40 grams per mole. Is this my big M or little m here?
Big.
Big M. Okay, good. This is my molar mass. And then my little m is over here, which is 7 grams. Okay, so we'll just plug that into our formula. So N is equal to mass of sample, which is 7 grams, divided by our molar mass, which is 40 grams per mole. Grams cancel, and I'm left with 0.175 mole. But if you wanted to do it into sig digs, how many digits are in 7 grams? 1. So this one should also go to 1. So it would be, and so in that case we need to look to the right of it. It's a 7, so we round up. So N is equal to 0.2 mole. Good? All right.